Part 2, Section 9. Here we go. Solve state number of types of roots. By the way, I just realized I forgot to do that on number 2. Number of roots is 4 total, which is what we'd expect. Then type is 2 imaginary and 2 real. Okay, let's go on to this one, number 3. Now, number 3, factor immediately if possible. I don't think so. Maybe factor by grouping, but we didn't really talk about that. Okay, so I think that might even work, but we didn't talk about it that much. So let's go to the graph and see how it goes. I think I've already got it loaded up here. So graph to find the easy zeros, easy roots. Turns out there's one easy root at -4. So I'm going to take and I'm going to divide out -4. So I get 1, 4, 5, 20 for the synthetic division. And I'm just going to go. So we'll bring down the 1, -4 plus 4 is 0. -4 times 0 is 0. Add them up, that's 5. -4 times -5 is -20, and I get 0. Okay. So I start off as a cubic. Now I'm down to a quadratic. So the equation that I'm at now, just to write it out for you explicitly, is x squared plus 5 times x plus 4 is equal to 0. And I want to figure out when is each part here equal to 0. Well, I already know this one is going to be x equals -4. That one showed up in the graph. Okay. Then I want to know when is x squared plus 5 equal to 0. Well, subtract 5, you get x squared equals -5. You square root. So you get x equals plus or minus the square root of -5, which is going to be 5i. Okay, so x equals plus or minus 5i. So that's my solutions. So there are 4 roots, 4 solutions. Same thing. Sorry, 3. Jeez, oh, Pete. Sorry. Count, Cresswell. 3 roots, 3 solutions. And 2 are imaginary. And 1 is real. Okay, you can see that from the graph as well. 1 real shows up. That means the other 2 must be imaginary. Last problem of chapter 4. Find all the zeros of this function. Now, this is the same question, essentially. All the work will be the same as if I had asked you to solve this equation set equal to 0. So let's go and find all the zeros. We're going to put this in the graphing calculator. We already have an x to the 4th here, so let's just fix this one. So minus 18x squared. I noticed right away that there's a cubic term missing, so we'll have to remember that when we do the division. So minus 18x squared plus 12x, and then plus 80. All right, and so that's my graph, and so then I check for easy zeros. Are there any easy zeros here? And so I pop the zeros there that are -4 and -2. There's the only 2, so I'm thinking ahead here. The other 2 must be imaginary because the 2 real ones showed up. So when we say find all, we mean find all real and imaginary. Okay, so let's do the division with -4 and -2. So let's move this over here. Those are my 2 easy zeros. So I'm going to put -4 in the box. Synthetic division. So 1, 0 is a placeholder for the cube term. Minus 18, 12, and 80. Bring down the 1. -4 times 1 is -4. Add them up. -4. -4 times -4 is positive 16. 16 plus -18 is -2. -2 times -4 is 8. Add them up. That's 20. -4 times 20 is -80. Add those up, you get 0. If you didn't get 0, then you did something wrong. Go back and try again. Okay, because it is a 0 of the graph, so you should get 0 for your remainder. All right, now -2 is also a 0, so we'll do it in another color here just to highlight what I'm doing. So I'm going to take -2 and, I guess we're good. Okay, -2, put that in the little box, and then we'll do synthetic division again. Bring down the 1. -2 times 1 is -2. Add them up, -6. -2 times -6 is positive 12. Add them up, that's 10. -2 times 10 is -20. You should get 0. If you don't, you did something wrong. Okay, so now I'm down to this number right here, or this quadratic right here. So to write that out explicitly, just to show you where we're at, I'm going to have x squared minus 6x plus 10. And that's all going to be multiplied by x minus 4, plus 4, and x plus 2. Okay, so that's where I'm at. I need to figure, I already know what the 0 of x plus 4 is, -4, and x plus 2 is -2. I need to figure out what the zeros of this are. In other words, I need to figure out what this is when it's set equal to 0. Okay, so to do that, we are going to need to use the quadratic formula. It does not factor. Okay, so we're going to use the quadratic formula, and we already know that our answers are going to be imaginary because they didn't show up on the graph. All right, so let's go quadratic formula here. Negative b plus or minus the square root. So negative b will be negative of -6. Remember, I'm working on this quadratic. So negative of -6 will be positive 6 plus or minus the square root of b squared. So that's -6 squared minus 4ac. So minus 4 times a, which is 1, times c, which is 10. Okay, all divided by 2a, which is just 2. So x is going to equal -6 plus or minus 36, the square root of 36 minus 40. That's -4. Okay, all divided by 2. And so this gives me -6. The square root of -4 is going to be 2i. So plus or minus 2i, all divided by 2. And then you can leave it like that, but you also might notice that -6 divides by 2 and 2 divides by 2 as well. So we can actually write our final answer simpler than that. It's -3 plus or minus 2 over 2 is 1, so plus or minus I. Okay, so this answer is my imaginary solution. So to sum up, all of the zeros, x equals 4, -4, excuse me, -4, x equals -2, and x equals -3 plus I and minus I. Okay, those are all of the zeros for my answer. Okay, follow those steps. Factor if you can, graph to find the easy zeros, divide them out, quadratic formula at the end if you need it, and that's how you'll find all the zeros. That's also how you will find all of the solutions. We also want exact solutions, okay? So like this one came out sort of nice with integers, but if we had like the square root of 5 as our answer, we would leave it as square root of 5. We wouldn't convert that to a decimal. We're working on finding the exact solutions or the exact zeros, okay? And that finally wraps up chapter 4 of Algebra 2.